Hello and welcome to another Applied Energistics 2 tutorial. In this video I will go through autocrafting, and that means all items that you will need to know to get going with autocrafting in AE2, and that will include standalone crafting in molecular assemblers, and then I will move on with crafting CPUs and crafting networks, how to request crafting from both assemblers and machines. And after that I will end with a little example of how to autocraft processors using what I will go through in the video. I won't go into very much detail, or rather I won't go into very advanced setups, but if I will make such a video I will put a link in the video description, and of course you should check there anyway, because there might be important information about this video and my other AE2 videos. So let's get started over here. First of all, we have the pattern terminal. This is what we need to make patterns, and we make patterns from blank patterns and make them into encoded patterns, of course, but I will come to that really shortly. And it can also be used as a crafting terminal, so you shouldn't need both of them. And next we have the blank pattern. As I said, you place it in the pattern terminal to make it an encoded pattern, and if you have an encoded pattern and you don't want it anymore, you can shift and right click to clear the pattern completely and reuse it, of course. There are two types of patterns. There are both crafting and processing recipes or patterns, but I will demonstrate that later on, so no need to worry about that now. The pattern is used to control crafting, and you can use it both in the molecular assembler as well as ME interfaces for both machines and assemblers. But we will start with the first one, the molecular assembler crafting. So just make one of those and place it somewhere where you have power. You can see it has power because it has some colors going on. And the molecular assembler is, of course, the machine that crafts items for you. There are two ways to use it. You can either place the pattern into the assembler directly, and this is called standalone crafting. And as you remember, I said there are two types of crafting, of two types of patterns, the crafting and the processing. And here we have to use the crafting. So let's place the pattern terminal and place our pattern inside. This is the button where you choose between crafting and processing, but we will only do the crafting right now, and go over there we'll make the processing. So yeah, here we are. So if I want to turn wood into planks, I make the recipe like this and I encode the pattern, and now we have an encoded pattern to craft oak wood planks with one oak wood. Now we place this into the assembler like that, but we can't put we can't put items like this. We have to, you can't put anything in the assembler, but when we have the pattern in, we can insert the wood to make planks. We can, and the envelope down here. We can also put items in the hopper and feed them into the assembler. This will automatically craft for us. This could also be another mod pipes or yeah, a lot of other mods that can automatically feed into the assembler and then suck out. But you can only have one recipe or pattern at a time. So yeah. We can change the setup slightly. Place the hopper on the side and we can remove these two. Now when we place hoppers in here, we'll get the feedback, the output directly back into. So that's pretty much what we can do with standalone crafting. I guess the real strength in standalone is to use other mods to feed. But we will move on, we will use similar method over here, but let's first move over here to begin with the crafting CPU and crafting networks. First we have the crafting unit. The crafting unit is mostly it's used as a component to craft other items, but it can also be used in the crafting CPU as a filler block. And a filler block is, well, it doesn't add any functionality, but it's a valid item to use in the crafting CPU over there. We'll get there in just a little bit. Next item is the crafting storage. Now these come in different sizes from 1K to 64K. And the storage provides more storage to the crafting CPU. And that means more storage for a job. And why do we need storage? Well, complex recipes, they require more storage space to handle the recipe. And also just making more out of one item or one pattern will also require more storage space. For example, crafting one wood into 4 planks, that would require 30 bytes. And if we raise that to use 16 wood to make 64 planks, that requires 120 bytes. And here I have the 1K storage, crafting storage, that is 1024 bytes. So I could craft a lot of planks at the same time, but when I fill up the storage, I will have to end the batch there and when it's finished, start a new one. Or I could use several or just make them larger in capacity. Next item is the crafting co-processing unit. The crafting co-processing unit, it provides additional item delivery from the crafting CPU to the interfaces. And what does that mean? Well, basically it means you can do more crafting at the same time. You can use several assemblers at the same time, and therefore we can speed up the total batch. When we do a big job, for example, then we would need lots of simultaneous crafting for different steps. And moving on, we have the crafting monitor. This is also a valid component of the crafting CPU. It's not required though. Well, actually the only required item is the crafting storage. Only one block like this is everything you need to have a valid crafting CPU. The co-processing and additional storage or a crafting unit or monitor, they are valid items to use, but not required. So let's craft the crafting monitor and move on to the last item to craft. Also, this is not a required item. This is the interface terminal. This just gives remote access to all interface patterns or all the pattern slots in the network. And I will demonstrate this in just a second. First, let's take another look on the crafting CPU. As I said, a crafting storage is actually everything you need to get started, and when your network grows to be larger and you have to do more things, you want to expand it to a larger crafting CPU. It's a multi-block structure and it has some rules to follow. As soon as I place another valid item, and the one that I have crafted now are valid items, for example another storage, now you can see it's not a valid crafting CPU anymore. So if I place, well, some, doesn't matter. Now we have 5 co-processing units. We have a crafting unit. It's just it doesn't add any functionality. And the co-processings are for more crafting at the same time. And the crafting storage is just additional storage to make larger jobs possible or more items at the same time. And the crafting monitor is just to monitor what's going on. It doesn't add any other functionality, and it's just a nice thing to have sometimes. The crafting CPU, it has to be a cuboid. So if I remove this item and place it over here, it's not a valid structure anymore. Come here, and I'll place you back again. And it can be a rectangular as well. So make it as large as you need it to fit the jobs you are making. Okay, so now it's time to get started. Let's place what we have crafted, the interface terminal like that, and the pattern terminal like that. So let's take a quick look at the interface terminal before we begin with any crafting. Here you can see we have furnace and 5 molecular assemblers and nothing else. But these 5 are spread out, and these 5 are this 1, 2, 3, 4 and 5 interfaces. Now we have 6 chambers, as you can see, and 5 interfaces. And this interface is exactly the same thing as this one, except this is a multi-block, so you can, or multi-part, so you can have 2 in the same block space, and you can also connect 2 interfaces to the same assembler. So if we take a look in one of them, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 patterns, 9 space for 9 patterns. And if we do it like this, we have 9 on this side and 9 on this side. So we have 18 possible patterns to use in this assembler. Now this can be quite useful like this one, where we have lots of patterns to use the same assembler. This is perhaps good when you have items that you rarely do, and this is a good setup if it's an item that you will craft a lot. For example, wood. It's used for a lot of things and you want to have the wood crafted quickly. Now let's take a look in the pattern terminal and make our first pattern for this side. We can perhaps make a pattern for a pattern like this. Okay, so we have a blank pattern, and we make sure to use the crafting pattern and not the processing pattern. So here we get the blank pattern, and now we have crafted one. So now we have a pattern for the pattern. All right. Now we can place it in the interface terminal, like here or here, over here. The problem is that I don't know where this is. You can use an inscriber or an anvil to name interfaces. That means it will be easier to find them here. So, but I can see if I can find it somewhere. Yeah, here it is. Okay, that sounds okay. So let's craft, how about 30? Here we can see the crafting plan. Now this means here we can switch between different crafting CPUs if we have different CPUs. I only have one, but we can have several on the network, perhaps one big and one small, and they can do different jobs. And we can see what we have available, and everything is available to craft 30. And we can see how big the job is in terms of storage. So 378. If I were to craft 100, it will take 1148 bytes, but that's okay because I have 2K. Well, if we have 1000, 11K, and I have no crafting CPUs large enough for that. So let's just do a few, okay? 30 to craft, automatic, that's okay. Start the job. Oh, it's not working. This is my bad. The reason why it's not working is because these are unpowered. So I will have to borrow a cable from somewhere. Please give me that. And we'll place it up here. So now we have power to these two, and they are being crafted. We can also see it over here. Perfect. This interface though, it will power all the assemblers, but these interfaces will not power the assemblers, but they will power each other. Okay. So we have our 30 patterns. So I think we can take them over here and we can move on. But perhaps before we move on, I can demonstrate using this one. That can be a good thing. So let's take my pattern and I place it over here. So now we have 3 assemblers, and if you remember the time it took for 30 to craft, let's see how quickly this goes. The number of bytes is the same because we have the pattern that is still only one interface. So let's start with that. And we made 3 simultaneously all the time. So quite a lot faster. So this can be quite useful, as I said, when you have one item that you will craft a lot of. Okay, now we can move on. Next thing I will check is making planks. So first we encode the pattern for planks, and then I craft one, and then we make a pattern for sticks. Encode, I craft the sticks, and let's, well, perhaps we can make a hoe, wooden hoe. So now we have 3 patterns, and of course I could use the interface terminal to just split them out like this. But I think I will place the wood in here actually. So I will place the wood, let's see, it was in the same as this one, right? So the wood over here, and then we have the other 2 in 1 each. So let's see how quickly we can craft, I don't know, 30, that's a good number I think. Now we'll craft wood, 2 planks, 2 sticks, and then craft the hose. Now we can see all 3 at the same time in different chambers. And yeah, and we're done. That was quite quick, and we have our 30. And now we can check how we can do that differently. We can, for example, we can place everything in the same. That's totally okay. We can use this for everything. This is a quite quick one, so perhaps it's quicker. And start. So planks, sticks, and hose at the same time. Perhaps that was even quicker. But yeah, this is more of advanced setups, how you design a good crafting network and how you divide items in large recipes. And I won't go into any deeper details about that in this video at least. Now let's move on to the last part of this side, of this part of the tutorial. Is the crafting recipe, or the processing, sorry. I want to make a processing pattern from cobblestone to stone. The processing pattern has no rules, except for that you have to follow. It has to be 100% output, not like a 10% chance or so. So it has to be the input is exactly the output, or the system will kind of hang, it will get stuck. So encode this pattern, and now we have a stone recipe, or stone pattern. So let's put that into the top of the furnace. This will insert on demand cobblestone into the furnace top, but we need something to cook with as well. So we can use an export bus on the side, and I will make a quick example of the crafting card. The crafting card is an upgrade, and it adds the crafting behavior of the export bus. You can use it on other items as well, but I will only quickly go through this as an example. And let me grab a stick. Craft me a stick, please. Perfect. I will need one. I can now use the export bus as a crafting device. I can use crafting behavior to, I can change the crafting behavior to use stocked items, or craft while exporting, or only craft while exporting. So it's what you would prefer. And let's place a stick in the middle. And now we see sticks ending up over here. And we can see I guess we should be able to see, yep, there we saw one. It will craft sticks now and then and slowly fill up the furnace with sticks. If that is what you want to have in there. You can of course export coal as well, but it was a good example. Now, if we just remove that, we should be able to order 30 stones from cobblestones. And here we are. Now this will keep the crafting CPU busy, so this will kind of prevent the creation of sticks. So let me see if I can fix that really quick. Okay, simple as that. I just borrowed a crafting storage from over there. So now we have 2 crafting CPUs on the network. So we have this large one and this small one. And now everything is automated. But what we see here is that we're filling up the sticks at the same time as we are working with the furnace. So if I can borrow this one as well. And here we can see the sticks from time to time and the stone are over there. So this is a good example of how you can make use of several crafting CPUs in the same network doing different things. Okay, that pretty much covers all the items I will go through in the video. So the final part is a quick demonstration of the automated processor, autocrafting of processors. So we place these back and see what we have. Yep. Okay, we have the system up and running. And what do we have here? We have one furnace that crafts silicon from dust, and we have 4 inscribers that, well, they do the printed parts, the silicon and the engineering and processing parts. And the final step is to craft the processors from the printed circuits. And we feed redstone and printed silicon, and this printed silicon is autocrafted. So everything you see here is what I've gone through before. So quick demonstration, we can start with the calculation processor. Craft me one of those. And we see the Certus quartz end up in here and then being sent over here, and that gives us the processor. And then the redstone will fill up, and and we need silicon. So we have silicon ending up here and going up. There, now it's finished. And that ends up over here. And that's valid for all of them. So we can craft engineering, one of those. And the logic 1 is, well, we have to finish that one first because we have only one CPU in the network. And now we can do a last. So, quite simple, even though it looks complicated. But if you understood everything in this video, you should be able to do this by yourself as well. If anything is unclear, just leave a comment and I will try to help you as good as I can. And also keep an eye out in the video description for links to other videos or more advanced videos, or just for general information. So thanks for watching, and I hope to see you in another video. Bye bye!